Welcome back. For the last 5 videos, we've been focused entirely on shaping the terrain. We've combined purlin noise, ridge noise, multiple layers of erosion, and an edge fade pass to create a terrain with realistic landforms and natural detail. But there's still one problem. It's still gray, it has shape, but it has no color, no surface definition, no materials. Today that changes. We're going to add the Splatmap Preset Node. Using information such as elevation, slope, and curvature, the terrain will automatically paint itself with the appropriate surface layers. Snow-covered peaks, rocky slopes, grassy valleys, and everything in between will be assigned automatically. And the best part? We'll do it all with a single click of Generate. Let's get started. I'm adding the Splatmap Preset node to the graph. This node is connected a little differently from the others. It doesn't sit directly inside the height map pipeline. Instead, it works as a separate branch that writes texture information directly to the terrain. I connect the terrain output of the terrain node to the terrain input of the Splatmap Preset node. Then I connect the height map input of the Splatmap Preset node to the output of the height map edge fade node. This height map connection allows the node to use elevation information when applying its painting rules. In other words, the node can decide where to place snow, rock, grass, and other layers based on the final terrain shape. In the inspector, under the preset section, we have a biome dropdown. I open it and there are several options available: alpine, desert, volcanic, tundra, tropical forest, temperate forest, savanna, Arctic, and Nordic Highlands. Looking at this terrain, it has a mountainous shape, visible erosion patterns, and a rough but slightly humid landscape character. So I'll choose Nordic Highlands. This gives us the feel of a Scandinavian-style mountain region: grassy valleys, rocky slopes, and snow-covered peaks. Now I click Apply Preset. Take a look at the inspector. The rules list has been filled automatically. We now have 8 rules, including wet moss, rocky grass, Nordic rock, wet cliff, highland grass, snow transition, snow cap, and one final fallback rule. Each rule has its own slope, height, and curvature settings, which tell PCGForge where and how each surface layer should be applied. Before the preset can paint the terrain, we need to assign the required terrain layer assets. This isn't something specific to PCGForge. It's simply how Unity's terrain system works. I'll switch to the Terrain Inspector and open the Paint Texture tab. In the Terrain Layers section, I click Add Layer. The Select Terrain Layer window appears, showing all the terrain layer assets available in the project. You can use the example layers included with your project or create your own custom terrain layers using your own textures and materials. Our Nordic Highlands preset contains 8 painting rules, which means we need 8 terrain layers assigned to the terrain. I'll add them one by one, matching the layers used by the preset. Once the layers are assigned, PCGForge will be able to automatically distribute them across the terrain based on elevation, slope, and curvature. I return to the graph and click Generate. That's less than 1 second. We're painting a 512 by 512 alpha map using 8 terrain layers with curvature pre-computation enabled, and it's still very fast. And now the result is ready. Take a look at the screen. The terrain finally has color. The valleys are green, the slopes are gray and brown, the peaks transition toward snow. With a single generate, we've placed a complete biome on top of the terrain we've been building throughout the last 5 videos. But let's fine-tune it a little. Let's explore the terrain from a few different angles. From a wide panoramic view, we can see green foothills, rocky bands across the mid-slopes, and snow near the peaks. It finally reads like a complete mountain silhouette. Now let's move closer and inspect one of the slopes. Look at the transition between rock and grass. It feels very organic. Thanks to the curvature information, concave areas appear slightly darker, almost as if moisture has collected there, while convex ridges expose lighter rock. Now let's move up toward the snow line. The transition between snow and rock isn't harsh. The snow transition rule creates a soft gradient, making the upper elevations feel much more natural. For now, I think this result is good enough, and at this point you already know how to adjust the rules for your own terrain. This is the final result of the 6-video terrain pipeline. The terrain is now ready to be played. Let's quickly add a character and test it in play mode. The character is standing on the terrain. I start moving. I'm running through the green valley with snow-covered mountains visible in the background. As I walk toward the slope, the texture changes into rock, and the erosion details become much more visible up close. I'm approaching the snow line now. The transition is smooth and natural. Running across the rocky area, the terrain collider works perfectly. What started as a gray height map over the last several videos has now become a playable mountain world. So, what did we accomplish in this video? We applied the Nordic Highlands preset using the Splatmap Preset Node, assigned the required terrain layers, adjusted the snowcap height, and tested the terrain in play mode for the first time. This is the result of combining the erosion pipeline with automatic terrain texturing, realistic landforms, organic material transitions, and a fully playable environment. What started as a simple procedural height map has evolved into a complete mountain landscape ready to be explored. And with that, our terrain series is complete. Over the course of 6 videos, we've built an entire terrain generation pipeline from scratch. Perlin noise and ridge noise for the base landforms, hydraulic erosion for channels and valleys, thermal erosion for slope stabilization, wind erosion for directional character, height map smooth for surface cleanup, height map edge fade for natural terrain boundaries, and finally, Splatmap presets for automatic biome texturing. In the next videos, we'll move beyond terrain generation and start exploring the other systems inside PCGForge. We'll cover scatter generation, road networks, and biome placement, and see how they work together to build large-scale procedural worlds. If you enjoyed this series and want to see more PCGForge tutorials, don't forget to subscribe. See you in the next video.